So good morning, welcome back. Today we're going to be working on some practice problems and see some examples for working with confidence intervals. So hopefully this is helpful. We've got a Pear Deck to do today. So we'll see how that works out. All right, if you do have questions along the way, please raise your hand, unmute your mic and tell me, or put them in the chat. I'm more than happy to clarify and answer questions along the way. All right, so let's get this thing going. All right, so here we are, confidence intervals, the basics, examples, and practice problems. All right, so how much does the fat content of brand X hot dogs vary? This is an example for you guys. I'm just going to work through this one together. There's not part of the Pear Deck for you to type into here. To find out, researchers measured the fat content in grams of a random sample of 10 brand X hot dogs. A 95% confidence interval for the population standard deviation is 2.84 to 7.55. All right, we want to, number one, interpret the confidence interval, and number two, interpret the confidence level, and lastly, answer this true or false question that the interval from 2.84 to 7.55 has a 95% chance of containing the actual population standard deviation, sigma. And we'll provide a justification for that. All right, so remember, we do want to keep in mind confidence interval and confidence level are different. They're very closely related, but they are different. No, it's not working this time. Come on. That's what I need to do. Sorry, click the wrong button. So the researchers are 95% confident that the interval from 2.84 to 7.55 grams captures the actual value of the standard deviation of the fat content of brand X hot dogs. Right. So the verbiage being used is very important. We're saying we're 95% confident. We are not saying there's a 95% chance or a 95% probability. We're saying we're 95% confident that the interval, right, captures the actual value, right, or that the actual value is in our interval, essentially. And we're saying we're talking about the standard deviation. That's the point estimator that we're using of the fat content. So we're being very specific about what we're talking about. Interpreting the confidence level, right? If many samples of 10 hot dogs were taken, or if we repeated the sampling process over and over again, about 95% of them will result in an interval that captures the actual standard deviation of the fat content. Okay, so again, in interpreting a confidence level, it's important to say, like, okay, well, if I were to do this sampling process many times, or repeat this thing over and over again, about 95% of these samplings would result in an interval that captures the actual, parameter that I'm interested in. In this case, it's the standard deviation. So again, I'm not saying that there's a 95% chance of my standard deviation being in the interval. I'm saying that 95% of the intervals will have the standard deviation within them. It's a totally different statement. And lastly, the third statement there is false. Right? This particular interval either does, probability of 1, or does not, probability of 0, contain the actual standard deviation. We don't know the actual standard deviation, so we can't say whether it does or doesn't. But to say that the interval has a 95% chance of containing the actual population standard deviation is not correct, because it either does or doesn't. 100% chance or 0% chance. There's a 95% about 95% of the intervals that we get from this repeated sampling will have that. All right, so yeah, guys, it does appear as though my chat is not cooperating still. So the chat, if you've typed something in the chat, the good mornings that people typed 10 minutes ago just came through. So good morning to those of you who said that. So if you do have a question, you will have to unmute your mic and ask to make sure that I get it. Otherwise, it will be at least 10 minutes delayed, and that's not super helpful. And they're not coming through in the chat, in the meeting chat, they're coming through the posts on the feed for the team, so it's a little bit messed up right now. So I do apologize, guys. I'm not sure why that's happening. So again, if you have questions, the best thing to do is unmute your mic and ask right now, because my chat is not working. All right. So for our first example here, are there any questions? Is there anything I can clarify? Okay. Well then, in that case, go to our first question here. All right. So question 1, going to the problem. For this context, you want to determine the point estimator, right? Are we using a sample mean? Are we using a sample proportion? It's going to be one of those. It's not, you don't need to find all of them. We can't find all of them with the information we have. So select the 1 point estimator, right? And then that you would use and calculate the value of the point estimate. So what is the point estimator you're going to use? Sample mean, sample proportion, sample standard deviation. What can you use given the context? And then what is the value of the point estimate? So our context is Tanya wants to estimate what proportion of the seniors in her school plan to attend the prom. She interviews an SRS of 50 of the 750 seniors in her school and finds that 36 plan to go to the prom. Alrighty, so we're going to talk about this. So a lot of you guys have some very good ideas. Some of you guys have the right answer. Some of you guys are on the right track. Some of you guys look a little confused because you're giving answers for more than one estimator, which we aren't supposed to do. So let's look at what the solution should be. All right. So here's the actual solution. Right. Our point estimator would be the sample proportion, or p hat. Right. That's the point estimator. The point estimate, the value of our estimator, is 0.72. Right. 36 out of the 50 students in our sample. Okay, the sample size was n equals 50. Right? We don't have the values to be able to determine a mean. That would be a different type of problem. We also want to look at the keywords here. We have that Tanya wants to estimate what proportion. Right? That should help lead us in the right direction there. Is there anything I can clarify about this question? Is there any questions? So again, guys, please remember that my chat is not cooperating. So if you do have questions, you have to say them on your microphone. All right, so then next. Our next question here, prayer at school. And this is a multiple part question. A New York Times CBS News poll asked a random sample of US adults the question, do you favor an amendment to the Constitution that would permit organized prayer in public schools? Based on this poll, the 95% confidence interval for the population proportion who favor such an amendment is 0.63 to 0.69. Right, so that's the interval. The lower bound is 0.63, the upper bound is 0.69 of the 95% confidence interval. Right. Question A is interpret the confidence interval. What does this mean? Right. B, what is the point estimate that was used to create the interval? What is the margin of error? And C, based on this poll, reporter claims that more than 2/3 of US adults favor such an amendment. Use the confidence interval to evaluate this claim. Right, so you might want to look back at your notes for part A and look at the verbiage we want to use when interpreting a confidence interval. We want to make sure we're writing our responses in the proper verbiage. Right. For parts B and C, take a stab at them. We'll talk about the solutions to those in a little bit. But see what you can come up with. Try to be creative. How could we determine our point estimate? How could we calculate the margin of error based on what you know? Okay, so I'll give you all some time on this. If you have questions, please let me know. Just unmute your mic and ask, and we'll talk about this in a few minutes. Alrighty, guys. We're going to talk about this one. I know that many of you are still in the process of working on this one, but in the interest of time, I'm trying to keep us moving so that we can see lots of problems. So many of you have answers for part A, interpreting the confidence interval, and many of the interpretations I saw were very well done and written properly. So that was good. So we're going to check out our solutions here. All right. If you're in the middle of typing stuff, I apologize. You will have the opportunity to look back into this if you choose to do so. All right, so for part A, they are, wherever they are, 95% confident that the interval from 0.63 to 0.69 captures the actual proportion of US adults who would favor an amendment that would permit organized prayer in public schools. And again, we're trying to be as specific as possible. We're using 95% confident, not 95% chance or 95% of our results or anything like that. We're 95% confident the interval from 0.63 to 0.69 captures the actual proportion. Not that 0.63 to 0.69 is the actual proportion, because it can't be more than one value, right? This range has it somewhere in there. For part B, the point estimate that would be used would be the sample proportion. We can find that by finding the midpoint between the upper and lower bound, right? Find their average. So we do 0.63 plus 0.69 and we get 0.66. So for the sample that was taken here in this context, 0.66 of those people surveyed, right, were in favor. That was the proportion. And the margin of error, right, we can find it by calculating one side of the, the difference between the sample proportion and the lower bound or the upper bound, right? And we get 0.03. So we have a margin of error of plus or minus 0.03. And that's because we add 0.03 to one side, subtract 0.03 from the other side of 0.66, and we get our upper and lower bound. Because the value, okay, so then part C, right? The reporter claims that more than 2/3 of US adults favor such an amendment. We're going to use our confidence interval to evaluate this claim. All right, so because the value of 2/3 is 0.667, right? and values less than that are in the interval of plausible values, there's not convincing evidence that more than 2/3 of U.S. adults favor such an amendment. Right, so even though that value is in our interval, because the interval also contains plausible values less equal to and less than that, it doesn't give us convincing evidence that their claim is true. Right? If the interval, like basically the lower bound was right about that number and the rest of the plausible values were greater than, that would give us better evidence, more convincing evidence. Okay, is there anything I can clarify on this question? Okay. We're going to move on to the next one. Question 3, shoes. All right, the AP Statistics class in a previous exercise where they took a simple random survey of 20 girls also asked for an SRS of 20 boys at their local school, how many pairs of shoes they have. A 95% confidence interval for the difference in the population means, girls minus boys, is 10.9 to 26.5. Interpret the confidence interval and the confidence level. And so this is very similar to the first example we saw today about the fat and the hot dogs. You're going to have two statements, one about the confidence interval and one about the confidence level. And again, you might want to look back at your notes at the verbiage that should be used in each of those. All right, guys. So that was 5 minutes on this one. We're gonna look at the solutions now, right? What the statements should look like, or one possible way to write the statements. I saw a lot of really good starts on your responses here. A lot of you guys had a really good idea of how to write the interpretation for the confidence interval with the correct type of verbiage. So that's good. So we're going to look at our solutions for this question. Okay. So these are the two possible statements we could have here. For the interval, right, they are 95% confident that the interval from 10.9 to 26.5 captures the actual difference, girls minus boys, in the mean number of pairs of shoes owned by girls and boys. Right, and again, it's really important that you don't say that the interval is the actual difference, because that can't be true. We can't have all of those numbers be the actual difference, right? We just know that it's somewhere in there, and we're 95% confident that it's somewhere in there. For the confidence level, if we took many samples of size 20 boys and 20 girls from the school, about 95% of the resulting confidence intervals would capture the actual difference in the mean number of pairs of shoes owned by boys and girls. Girls and boys, sorry. All right. So now when we're interpreting the level, right, that's referring to how often essentially our sampling, our sample proportions, right, or sample means would have a difference that resulted in a interval that contains the actual mean differences in mean, right? In that case, 95% of those would contain the actual parameter. So we might have some that don't. Can I give you guys any extra clarification or explanation on this question? So then we're going to go to the next one. This is also about the same context. We're adding to this question. Does the confidence interval give convincing evidence of a difference in the population mean number of pairs of shoes for boys and girls at the school? Right. So does the interval that we saw in the previous question, does that give us evidence saying that there is a difference between the average number of pairs of shoes owned by boys and girls? Okay, so that's what we're answering. Does that interval give us evidence? Okay, so I know some of you guys are still working on your answers, or still considering how to answer this, and probably some of you aren't quite sure how to even start answering this question. And that's okay. That's why it was chosen. So does the confidence interval give convincing evidence of a difference in the population mean number of pairs of shoes for boys and girls? So we have to carefully read this. It's basically asking, based on the data we collected, do we think there is a difference between the amount of shoes that boys own at school and girls? Based on the interval, the fact that our interval is basically from like 10 to 26, give or take some decimal places, that means the most plausible results say that there is a difference. All right. That means, come on. Why did this one not go forward? There it is. So yes, right. Since the value of 0, meaning there is no difference, is not a plausible value in the interval, there is convincing evidence that there is a difference in the population mean number of pairs of shoes for boys and girls at the school. All right, because the most plausible solutions or most plausible results are in that interval from like 10 to 26, saying that there is a difference. So we have evidence saying there is a difference. Okay. Is there anything I can clarify? You guys please keep in mind the chat is not working today. I don't know why, so if you do have questions, you have to unmute your mic and ask. Then we're going to go to the next question, which is a multiple choice question. Yep. So in a poll, 1, some people refused to answer questions. 2, people without telephones could not be in the sample. 3, some people never answered the phone in several calls. Which of these possible sources of bias is included in the plus or minus 2% margin of error announced for the poll? And you can select from 1 only, 2 only, 3 only, 1, 2, and 3, or E, none of these. All right, guys. Let's see. So I have, okay, on this one, there are 3 students who have the correct answer selected. All right, this one was a bit tricky. So let's look at the actual answer. None of these. It was option E. Each of these 3 biases are results of like undercoverage, right? Non-response, right? Those are things that are not considered in our margin of error. The margin of error is essentially only accounts for biases due to like sampling error, right? That is the only thing it can account for. Errors that occurred by chance. It does not account for undercoverage, overcoverage, non-response, right? Question bias, all those types of things can't be factored into this type of margin of error. So the answer is none of these. Is there any questions about that one? It was a little tricky. All right. We got one more question. This one having to do with confidence. You have measured the systolic blood pressure of an SRS of 25 company employees. A 95% confidence interval for the mean systolic blood pressure for the employees of this company is 122 to 138. Which of these following statements is true? You have 5 statements to choose from. Please read them carefully, right, and look for the proper verbiage, right, and select the statement you think is true. Only one of them is. All right, guys, let's look at the solution. And again, this one was tricky, right? And this comes down to making sure that the statement you chose, or that the correct statement, has the proper verbiage, right? The correct solution, the true statement, was statement C. If the procedure were repeated many times, 95% of the resulting confidence intervals would contain the population mean systolic blood pressure. The other ones, we're talking about probabilities, or it was talking about the sample or the actual population, and things were in the wrong order, right? This is the proper interpretation of the confidence level, right? So if we do this many times, 95% of the resulting confidence intervals from those samples would contain the population mean. Okay. Is there anything I can clarify? Then stop sharing my screen. All right, so that was the activity for today. Hopefully that helped you guys get a little bit better understanding of what a confidence interval is and how to interpret the confidence interval and confidence level, what a point estimator is, what a point estimate is, and those types of things. If you have any other questions, you'd like any other clarifications, please ask, please let me know. You can stick around on this call and ask, or you can send me a message, email, whatever later and ask. I do highly recommend doing the practice problems that are in Canvas for section 8.1. I'll have those solutions ready for that soon. Other than that, that's all we have for today. I hope you guys have a great rest of your week and a wonderful weekend, and I will see you next week.